If you travel to South Africa, you might find yourself looking at the Barberton Makhonjwa Mountains. From a distance, they appear as a series of smooth, rolling green hills that feel quiet and unremarkable. Beneath that grass, the rocks were forged 3.6 billion years ago. When these minerals were cooling in the crust, Earth barely resembled the planet we know today. The atmosphere lacked the oxygen we breathe, there were no forests and no birds, and almost all life was entirely microscopic. We usually expect the most ancient places on Earth to look grand or imposing. This quiet landscape forces us to reconsider that assumption. To understand the age of these rocks, think about the dinosaurs. They appeared about 230 million years ago. These South African hills are more than 10 times older than the very first dinosaur. If we compress Earth's entire history into a single 24-hour day, all of human civilization, everything we've built or remembered, would flash by in a fraction of a second right before midnight. Those ancient rocks formed in the early morning hours, yet Earth's surface is constantly under attack. Rain shatters rock, gravity pulls sediment downhill, and massive glaciers grind entire valleys into dust. Over billions of years, these forces should have erased every geological structure on the planet. And yet, this landscape is still here. The answer lies in a critical scientific distinction. When experts call a mountain ancient, they are referring to the age of the rocks themselves, not the physical shape of the modern peak. Mountains are active war zones between two massive planetary forces. On one side, you have erosion, stripping away thousands of tons of material, constantly trying to flatten the landscape. On the other side, you have tectonic uplift. Enormous plates beneath us slam together, compressing the crust and forcing massive sections of land upward. A rock survives 3 billion years by staying hidden. It spends the vast majority of its life buried deep in the crust, shielded from the wind and rain by miles of overhead rock, until tectonic forces eventually push it back to the surface. The rocks endure because they are part of a continuous cycle, alternating between long periods of burial and brief windows of exposure. If these rocks are some of the oldest on Earth, why aren't the mountains they form infinitely tall? Age doesn't build height, it guarantees exposure. The longer a mountain range remains above sea level, the more time water and wind have to shave away its peak. Massive, sharp, jagged ranges like the Himalayas are geologically young. They are tall because they haven't endured enough time to be weathered down. In contrast, the true elders of the planet have lost their sharp edges. They are smooth, low, and rounded. A mountain's lack of height reveals its endurance. It has stood its ground against the elements for billions of years. By surviving that cycle of burial and uplift, these specific formations function as perfectly preserved geological time capsules. Locked inside the minerals are chemical signatures that reveal the state of Earth's oceans and atmosphere billions of years ago. These rocks contain isotopes and minerals that record the exact planetary conditions present when the first microscopic life emerged. These rare, surviving outcrops are the only physical records we have left to reconstruct the origins of our world. We tend to think of Earth's deep history as a theoretical concept, an era that happened long ago and then vanished into the past. But the past is physically still here, built into the layers of rock and geography surrounding us. You don't need a time machine to see the primordial world. The evidence is sitting directly beneath our feet. When you look at an ancient mountain, you are witnessing Earth's physical memory.